cardiovascular system. This part of anatomy usually makes a lot of sense to most students. So it might take a minute at first to get it, but it tends to stick. So before we get into the details about the cardiovascular system, I want to kind of go through sort of the anatomical and functional plan for the cardiovascular system. So let's see. At the top of this set of notes, the plan for the cardiovascular system is, although people generally refer to the heart as a pump, I would argue that it's actually two side-by-side pumps because each side is receiving from a different place and pumping to a different place. The left side, and by the way, we're looking at this heart in this picture as if we were looking at a patient, right? So this is their left side. The left side of the heart is really going to be dealing with high oxygen or oxygenated blood, and the right side of the heart is going to be dealing with low oxygen or deoxygenated blood. The left heart and the right heart both have upper chambers called atria, singular is atrium, lower chambers called ventricles. So let's do the left side first. Big picture understanding, and we're going to kind of draw this out in a minute too, is that the left side of the heart, the left atrium, is actually going to, hold on, where are we going into the left atrium? Left atrium right here is going to be receiving blood from the lungs where it was just oxygenated. Function of the lungs. And then the blood is going to go from the left atrium into the left ventricle, and then the left ventricle is going to pump that high oxygenated blood to all other organs in the body, including brain, digestive organs, pretty much everything, except the heart. Except the lungs. And then the right heart, right here, the right heart is going to be receiving deoxygenated blood, low oxygen blood, from those organs and tissues, right? Just went through here and you pumped it, for instance, to the digestive organs, and then it's going to go back to the right atrium. It's going to be receiving that deoxygenated blood. Then it's going to go to the right ventricle, still deoxygenated, and the only good place to send blood like that would be back to the lungs. So it's kind of like two interlocking circles. So we're going to draw this in a simplified version in just a second. So basically what you end up with is two circuits. One of them comes from the left heart, left ventricle, goes through what we call systemic organs and then back to the right atrium. The other one goes from the right ventricle through the lungs and then back to the left atrium. So let's draw a simplified version of that. Okay, so we're going to represent the heart as simply as possible, just as a box, right? With the top two chambers that you can see right here being the right atrium and the left atrium, and the bottom two chambers, the right ventricle and the left ventricle. And we're looking at these as if we were looking at a patient as well. Now, it doesn't really matter where you start this story, but I am arbitrarily going to start it at the left ventricle. Ventricles are your primary pumping chambers, and so blood is always going to leave the heart through ventricles. There are valves involved there. We'll deal with the valves in a little bit. It's going to leave the heart through a ventricle. And when you are leaving through a vessel, okay, this vessel is called an artery, regardless of the oxygen content that it has. And what this blood is going to do is it's going to go to, let's see, all organs except the lungs. As it goes through the organs, it's going to go through the capillary beds. Blood is only going to exchange gases in capillary beds. So where we started out, we are delivering nice, rich, high oxygen blood. It's coming from the left ventricle and it's going to the organs. Then when it gets on the other side of the organ, it is going to be low oxygen, because it just went through those capillary beds. And then what we are going to do with it is we are going to send that low oxygen blood back to the right atrium. Okay? Low oxygen blood is going to be in the right side of the heart, so it's going to go into the right atrium. Okay? Now, this vessel right here, because it is carrying blood toward the heart, it is a vein. Regardless of the gas content, it's a vein by definition if it's carrying blood toward the heart. Okay, and then now that we're in the right atrium, we are going to go through a valve. We'll name the valve in a little bit. From the right atrium to the right ventricle. Okay, we're in the right ventricle, and now we have this low oxygen blood. Ventricles pump, but where does it make sense to pump this blood to if it is low oxygen? So it is going to be leaving, and the only good place to send blood like that is the lungs. That's a bad picture of the lungs. Looks more like testicles, but it is not. Okay, it's going to go through the lungs, and again, the blood is going to be low oxygen on this side because that's what it was. Okay, and then it's going to go through the lungs. As it goes through the lungs, it's going to be oxygenated. And on this side of the lungs, it's going to be high oxygen. Okay, now we've got nice rich blood that we can send back to the left side of the heart. Okay, we are going to send it back to the left side of the heart. So let's name a couple of vessels, even though it's counterintuitive. So this vessel right here, that was leaving the right ventricle, still had low oxygen, right? It was low oxygen all the way through. It was low oxygen as it went into the right atrium, low oxygen in the right ventricle, hadn't gone through a capillary bed yet, so it's still low oxygen, but it's being pumped away from the heart, so this vessel is actually an artery, okay? Even though it's got low oxygen. A lot of people get into the habit of naming arteries and veins by their gas content, but that's actually incorrect. Arteries and veins are named for the direction that the blood is flowing. If the blood is flowing away from the heart, like in this situation or this situation, it's still an artery. Okay, but then on this side, when we're over here, blood is going back toward the heart. So what is that? That is a vein, even though it's high oxygen. Okay, it's going to go back into the left atrium. So we're going to go back in here. And then we will start the whole story all over again because we go from the left atrium into the left ventricle, and then we will do the whole story all over again. So the important thing to understand is that the big picture of the cardiovascular system is really that there are two circuits. One of them is called the systemic circuit right here. And it is the one that is really involved in delivering oxygenated blood to capillaries and then back to the heart. So this is systemic circulation that you see right here, systemic circulation. This is also part of systemic circulation up here. So delivering oxygenated blood to capillaries and then back to the heart. And then the other circuit is delivering deoxygenated blood here to the lungs and then back to the heart. That's called pulmonary circulation. So there's two different circuits in the heart. Okay, so big picture of understanding the vessels that are involved. By definition, an artery is a vessel that takes blood away from the heart. So this vessel right here, is an artery, but so is this vessel right here. Because it doesn't matter what the gas content is, it matters which direction the blood is going. Arteries are, by definition, relatively large, muscular-walled vessels because they're under high pressure, because they're right next to the heart, or they're receiving high-pressure blood from the heart. And in an artery, the blood can either be oxygenated or deoxygenated. The blood will be oxygenated in the systemic circuit arteries, and it will be deoxygenated in the pulmonary circuit arteries. An arteriole, not shown in this picture, but just for future reference, is when the arteries get so small they're hardly visible with the naked eye, and they're not usually named at that point either. And then the arterioles will lead to the capillaries. And again, important part about capillaries is that the capillaries are the only places that you do gas exchange. So you will see blood go from oxygenated to deoxygenated as it goes through a capillary bed. Then the venules are very small veins. They are carrying blood back toward the heart. They're usually too small to name. And then the veins are, by definition, carrying blood back toward the heart. And again, it does not matter if the vein is carrying oxygenated or deoxygenated blood. It's a vein by virtue of carrying blood toward the heart. Okay, so let us, now that we have a little bit of an intro, there's an animation I've linked for you, and I want to listen to this animation. This is the linked video, just a little 2-minute video to introduce structure function of the heart. It's the same thing we're going to be talking about.
Veins are blood vessels containing blood flowing to the heart, while arteries have blood flowing from the heart. The blue is representative of blood vessels containing deoxygenated blood, while the red blood vessels have oxygenated blood fresh from the lungs. Now, let's follow the path of the blood through the heart. The superior vena cava receives blood from the head, neck, upper limbs, and chest. Meanwhile, the inferior vena cava receives blood from the trunk, viscera, and lower limbs. Both the superior and inferior vena cava end up in the right atrium, one of the 4 chambers of the heart. The heart not only has 4 chambers, it also has 4 valves. The purpose of the valves is to keep blood moving in the right direction and not flow backwards. Blood exits the right atrium through the tricuspid valve, so called because it has 3 flaps, and enters the right ventricle. The blood exits the right ventricle through the pulmonary valve and enters the pulmonary artery. Again, it is an artery because blood is flowing away from the heart, but it is blue because it lacks oxygen. The pulmonary artery then splits into the left and right pulmonary arteries, which go to each respective lung. In the lungs, gas exchange occurs. The blood discards carbon dioxide and picks up oxygen. Now, blood comes back from the lungs through the pulmonary veins, entering the left atrium. Next, the blood is pumped into the left ventricle through the mitral or bicuspid valve. Finally, the oxygenated blood leaves the left ventricle through the aortic semilunar valve, entering the aortic arch. The aorta, which is the largest of all the arteries, distributes the oxygenated blood to the rest of the body. The aortic arch has 3 major branches, which supply the head and arms with blood. Then the aorta curls downward behind the heart, forming the descending aorta, which descends through the chest and continues down through the abdomen. In the abdomen, the descending aorta splits to supply the pelvis and legs with blood.
If you like this video, please like.
Okay, so that's a little intro to the stuff that we are going to be doing.